Alright, here's 1-1, part 2. This is going to be your favorite part because it's loads of word problems. Alright, so the first one we're going to do is a distance, rate, and time. And so the first thing you want to do is write down what your formula is. Distance is equal to rate times time. So if we go through and read what it says distance along a shipping route between San Francisco and Honolulu is 2,100 nautical miles. So we've got San Francisco and Honolulu. The distance here is 2,100 nautical miles. If one ship leaves San Francisco at the same time another leaves Honolulu, and if the former, the San Francisco, travels at 15 knots, and the later, which is the Honolulu, travels at 20 knots, how long will it take the two ships to rendezvous, and how far will they be from Honolulu and San Francisco at that time? So think about what it's asking you. How long will it take the two ships to rendezvous? So you know you're going to want to figure out time. And we have the rate. So what we're doing is we're doing the distance of the first plus the distance of the second is going to equal our total distance. Well, let's do the easy part first. The total distance is 2,100 nautical miles. The distance of the first is going to be, here's its rate, so it's going to be 15t plus the distance of the second, which is 20t. Alright, now if we go through and start solving this, we're going to combine and we get 35t equals 2,100, divide by 35, divide by 35, and we've got that t is going to be equal to 60. Now it's nautical miles, so that's going to be 60 hours. So that takes care of our first part of our problem on how long will it take the two ships to rendezvous. Now, how far will they be from Honolulu and San Francisco? Well, if they're going 60 hours, so for San Francisco, we've got 15 times the time, so you end up with 900 nautical miles. And then for Honolulu, we've got, this is for Honolulu, we've got 20 times 60, and therefore you end up with 1,200 nautical miles. Alright, that's it. Let's go. Alright, here's where I want you to give it a go. So go ahead and pause and let's see if you can get it right. At least try to set it up. Alright, here's the answer, and I hope you guys got it right. Let's move on. Alright, now we're going to do a distance, rate, time problem. So again, we're doing distance is equal to rate times time. An excursion boat takes 1.5 times as long to go 360 miles up a river as to return. If the boat cruises at 15 miles per hour in still water, what is the rate of the current? So we need to set this up. This one's a little bit more involved, but let's say that x is equal to the rate. Alright, so the rate upstream, it says if the boat cruises at 15 miles per hour in still water, think about it, if it goes upstream, it's going to go 15 miles 15 miles per hour minus the rate because it's going to go slower, so that's upstream. Now for downstream, it'll go 15 plus the rate of the water because it goes faster going downstream. Alright, so now we need to think about how we're going to solve this. Let's think about what we're given. We're given the rate and we're given the distance. We're giving those two things. So that's what we need to use. So we need to change our equation, divide by r, and get distance divided by rate. So we need the distance upstream. Well, wait, let's think about something else. Don't forget, an excursion boat takes 1.5 times as long to go 360 miles up a river as to return. So the time upstream is going to be 1.5 times as long as downstream. right? Okay, so now we need to figure out, we got distance upstream. So for the time up, we have to do the distance. We know the distance is 360 miles. Here's the time, there's the distance, and the rate up is 15 minus x is equal to, and then we need to do the downstream, and that's this part, so 1.5 times, again, the distance, and the rate for down is 15 plus x. Okay, now the best way to handle this, I think, is to go ahead and multiply the 1.5 all the way through. Let me make this smaller so we have more room. Alright, so we've got 360 over 15 minus x, and this is just like doing a fraction. So 1.5 times 360 is 540 over 15 plus x. Now go back to elementary days and do that cross multiplying. So if we cross multiply, we would have 360 times 15 plus x, and then the other one would be 540 times 15 minus x. Alright, so 360 times 15 is 5,400 plus 360x is equal to 5,400, or 540 times 15 is 8,100 minus 540x. So let's take the 540x over, 540x, 540x, and we've got 5,400 plus, and that's going to be 9. So again, 900 x is going to equal 8,100, subtract 5,400, subtract 5,400. This is basic algebra here. So 900x is going to be, let's see, that's going to be 2,700. And divide by 900. Alright, I'm running out of space, so, oops, I forgot to put the pencil back on. Divide by 900, and you'll end up with x equals 3. So the rate of the current is 3 miles per hour. Alright, let's go to the next. Alright, an advertising firm has an old computer that can prepare a whole mailing in 6 hours. With the help of a newer model, the job is completed in 2 hours. How long would it take the newer model to do the job alone? So we need to figure out how we're going to set this up. So we're going to say, let's let x equal time. Okay, again, this is a quantity rate equals time. That's going to be for the newer model. Alright, so now we got to think about what we're going to do with, let's see, a whole mailing, and the old computer can do it, a whole thing, in 6 hours. So the old can do it in 6 hours. Alright, so now we got to think the rate of the old model compared to the rate of the new model. So that means the rate of the old can actually do it in 1/6 of the job per hour. We want to go per hour. This is 6 hours. So to do per hour, we do 1/6. This is for the old. The rate of the new is, we don't know, so it's going to be 1/x job per hour. Okay, if you add these two together, you should be able to get the whole job done. So if we do the rate of the old plus the rate of the new, that would equal one whole job. Alright, so the rate of the old, now it tells you here that it can get the whole, with the help of the newer model, the job is completed in 2 hours. So if we say, okay, the old one does it in 1/6 of the 2 hours, plus the new one, which is 1x of the 2 hours, should get the one whole job done. Alright, so what we have now is we've got, this is going to cancel, so we got 1/3 plus 2 over x equals 1. Alright, let's get rid of our fraction, multiply everything by 3. So now I have 1 plus 6, multiply by 3x. That way we can get rid of the whole fraction. So this is going to be x plus, let's see, cancel that, 6 equals 3x. Subtract x, subtract, this is x, and let's go over here and make ourselves a little bit more room. So I've got 6 plus 2, or 6 equals 2x, divide by 2, and x equals 3. So therefore, the new computer can do the job in 3 hours. Alright, the next one we're going to do is a mixture problem. How many liters of a mixture containing 80% alcohol should be added to 5 liters of a 20% solution to yield a 30% solution? So, we're going to do the amount. Now remember, anytime you have percentages, you should change it to decimals. So this is 0.8, this is 0.2, this is 0.3. Alright, so we do the amount of alcohol in the first solution, which is 0.8 times how many liters there are, plus the amount of alcohol in the other, 0.2, let's do it this way, let me stay consistent, times 5 is going to equal to 0.3 times x plus 5. Alright, now why do we do that? Because we know that here we've got x liters, right? We knew here we have 5 liters, so therefore the final solution has to have, adding these 2 liters together, x plus 5. So I've got 0.8x plus, and 0.2 times 0.5 is 1, equals 0.3x plus 1.5. Alright, so we'll subtract 0.3x, subtract 0.3x, and we get 0.5x plus 1 equals 1.5, minus 1 minus 1. 0.5x equals 0.5, therefore x equals 1. So you have to add 1 liter of the 80% solution to get what you are asking for, to yield a 30% solution. Alright, we're done. So again, here's your homework, and you should be able to do it. Good luck.